Good morning, everyone. Today we are going to learn about Poisson distribution. At first, we should know the concept of Poisson distribution. Poisson distribution is a method in which we find the probability of a specified number of events that occur at certain interval of time, area, and volume. We understand the Poisson distribution from one example. The example is during the first hour of office time, a manager receives 2 phone calls on average. Find the probability that during one particular hour there will be no phone call at all, exactly 5 calls and at least 3 calls. So as per the example, we are given the information is the average number of calls, the average number of call that is denoted by lambda, which is 2. And at Poisson distributions, one parameter should be known, which is average value of the event. That means which has been derived from the past experience. So here, the information of 2 that representing average number of calls that the manager receives during the first hour of office time. So from this information of lambda, we calculate the given questions by using Poisson formula as per the Poisson distribution function p x equals to r equals to exponential terms of Poisson distribution, that is indicated by e power to the minus lambda multiply lambda power to the r divided by r factor. Here e power to the minus lambda means 2 multiplied by 2 power to the r and then r factor. So what is the first questions? The first question is, what is the chance of getting no phone call at all? That means first I. P, the chance of getting no phone call at all. P, no calls. It means P x equals to exactly 0. So putting the Poisson distribution functions in this case, e power to the minus 2 multiplied by 2 power to the 0 divided by 0 factor. 0 means desired success. E power to the minus 2 means what? 0.1353. 0.1353 multiplied by 2 power to the 0 means 1. And 0 factor indicates 1. It means 0.1353 or 13.53%. The answer indicates that there is 13.53% of probability of getting no call at all by the manager during first hour of his time. Second question is, what is the chance of getting exactly 5 calls? P, exactly 5 calls. 5 calls. It means P x equals to R, x equals to 5. So e power to the minus 2 multiplied by 2 power to the 5 divided by 5 factor. E power minus 2 means 0.1353 multiplied by 2 power to the 5 means 32. And 5 factor means 120. The result is 0.0361 or 3.61%. It means there is chance of 3.61% of getting exactly 5% by the manager during first hour of his time. And third question is probability of getting at least 3 calls. At least 3 calls. 3 calls. It means at least 3 calls means 3 calls or more than 3 calls. So it means the total probability is indicated by P x is greater than or equal to 3. That means P x equals to 3 plus P x equals to 4 plus P x equals to infinity. It means because the last fixed number of trials are not given here, here 1 minus P x equals to 0 minus P x equals to 1 minus P x equals to 2. 1 minus x equals to 0. The chance of getting no call is 0.1353 minus px equals to means e power to the minus 2 multiply 2 power to the 1 divided by 1 factor minus e power to the minus 2 multiplied by 2 power to the square divided by 2 factor 1 minus 0.1353 minus 0.1353 multiplied by 2 divided by 1 minus 0.1353 multiplied by 4 divided by 2. 1 minus 0.1353 minus 0.2706 minus 2706. So all together from the by subtracting 0.1353 minus 0.2706 and 2706 from the 1 is 3235 or 32.35% of probability of getting at least 3 calls by manager. Okay, in this way, we can calculate the Poisson distributions from the given example of lambda, that means average number of calls. And the second example of the Poisson distribution is a machine makes pins on average 2 in 400 pins are defective. If the pins are packed in box of 100, what is the probability that in any box will contain no defective, exactly 3 defective, and the last one is less than 2 defective? So from these informations, we write the given at first. The given information is the given information is the sample box contains 100. It means sample size 100. Sample size, it is better to write sample size rather than number of trials in Poisson distribution. Sample size small n equals to 100. And probability has to be computed from the information. The information is that there is 2 in 400 pins are defective. The question has focus on the defective item. So defective item can be assumed to be success event. Here the number of defective item in 400 equals to 2. So here we can obtain the sample proportion from the relationship of 2 and 400. The sample proportion can be obtained as P equals to 2 divided by 400 equals to 0.005. Here the sample size in a box is 100 and the sample proportion is obtained as 0.005, which is the result of 2 defective in out of 400. Here we must have the single parameter in Poisson distribution, which is lambda. That means the average number of event, and it can be calculated as n multiplied by p. So here mean, that means lambda indicated by lambda equals to n multiplied by p. N means 100. Probability means the sample proportion, which is 0.005. So here the parameter lambda is obtained 0.5. As per Poisson distribution function, Px equals to r e power to the minus lambda, that means exponential term of Poisson distribution multiplied by lambda power to the r divided by r factor. The exponential terms as e power to the minus 0.5 multiplied by 0.5 power to the r divided by r factor. So from this Poisson distribution functions, now we can solve different types of questions as per given information. The first question is no defective. What is the chance of getting no defective? No defective from the box that contains 100 items. P x equals to r, x equals to 0. P it means e power to the minus 0.5 multiplied by 0.5 power to the 0 divided by 0 factor. What is the value of e power to the minus 0.5? 0.6065 multiplied by 1 divided by 1. It means 0.6065, that is, or 60.65% of getting no defective from the 100 items. And the second question is P exactly 3 defective. 3 defective. P x equals to 3. E power to the minus 0.5 multiply 0.5 power to the 3 divided by 3 factorial. 0.6065 multiplied by 0.125 divided by 6. The answer is 0.0126 or 1.26% chance of getting exactly 3 defective out of 100 items in a box. And the third question is P less than 2 defective. 2 defective. It means Px is less than 2 defective. Am I right? Px equals to 0 plus Px equals to 1. X equals to 0 means 0.6065 plus x equals to 1 means e power to the minus 0.5 multiplied by 0.5 power to the 1 all divided by 1 factor. 0.6065 plus 65 0.6065 multiply 0.5 divided by 1. So the answer is 9098. It means 90.98% chance of getting less than 2 defective out of 100 in a box. So here we can use the Poisson distributions when the chance of getting a specified number of events is very rare. That means less than 0.05.